Hello everyone, this is Rahul Sresht here to present the second part of the chapter Rest and Motion for Class 8. So, in our last video, we read about rest and motion and learnt how objects in motion cover certain distances per unit time, which is termed as speed. And today, the topic of our discussion is velocity. If you remember, in our last example, when this car moved 20 meters in 5 seconds, we got our speed to be 4 meters per second. And this speed of 4 meters per second tells us how fast the car is moving. And it also can tell us the distance we will move from the point of origin if we move with that same speed for a set amount of time. Suppose if I move with this speed for 1 minute, which is equal to 60 seconds, can we calculate how far I would travel and how much distance I would cover by that time? Yes, we surely can. Simply by using the definition of speed, which tells us that it is the rate of change of distance, where rate means divided by time, so speed is distance by time. And by rearranging these quantities, we can get the distance to be the product of speed and time. So placing all these known quantities in the respective places, we can find the distance to be precisely 240 meters from the point of origin. But if I covered 240 meters from this point, can you tell my exact location? If I'm here, 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 or here right now? Is this much amount of information of me telling my speed and the time I traveled enough to know my exact location? See, the thing is that speed is a scalar quantity, which means that it only conveys us the magnitude of distance that we covered in a certain amount of time, but it does not express the direction in which this distance is being covered. And for this reason, you cannot determine my actual position. But suppose if I say that I traveled with the speed of 4 meters per second for 1 minute towards the east direction. Now this sense of direction of me traveling towards the east can precisely help to determine my exact location, which will be somewhere around here towards the east of my point of origin. And this total concept of specifying speed along with the direction is what is known as velocity, which is a vector quantity. Basically, the quantities that are expressed using both magnitude and direction are the vectors, and the quantities that are to be expressed using magnitudes only are the scalars. So you can say that velocity and speed are quite a lot similar to each other except for one simple difference, and that difference is direction. Basically, velocity is nothing but speed expressed along with direction. And if we look at the definition of velocity, it is the amount of distance covered in a particular direction per unit time, and can also be defined as the rate of change of displacement, which can be denoted as displacement upon time. As I already said, that rate means divided by time. So now if we compare this formula with the formula of speed, we can see that here the difference is just of displacement and distance. So let's understand these topics first. As we already know, that distance is the length between any two given points, or in the case of conveying speed, we can also define distance as the total length of the path covered while we were in motion. So suppose if you are going to your school from your house, taking this route, then the distance you traveled is basically the total length of this path that you took. Let's say the distance is 3 kilometers. But are you actually 3 kilometers far from your home? See, It's for sure that you traveled 3 kilometers along the length of the path that you took. But how far you are from your home is a totally different concept, which is called displacement. Displacement simply refers to the shortest distance between your initial and your final positions. And that's why the word displacement, where dis means change and placement means your position. So displacement is basically the measurement of the change between your initial and your final positions. Now, if you see, the shortest distance between your initial and final position will be this straight line from your house to your school, which let's suppose is 1.5 kilometers. Also understand that displacement is a vector quantity as opposed to distance, which is a scalar, which means that we need to specify the direction in which the object moved while expressing its displacement, which in this case is towards the northwest direction. So the distance you traveled in this case is 3 kilometers, while your displacement is just 1.5 kilometers towards the northeast direction. Now understand that while moving in a straight line in a single direction, the magnitude of your distance and displacement will be the same. But it will not be the same if you change your direction. So in this case, because you moved 40 meters, the distance you covered is 40 meters. And in the same manner, your displacement is 40 meters as well in the east direction. But what if you suddenly decide to change your direction after traveling for 40 meters? And then suppose you traveled 30 meters towards the north again. Then here the total distance you traveled will be this 40 meters plus this 30 meters, which is 70 meters. But will your displacement be the same as your distance here as well? Let's see. We know that the displacement is the shortest distance between the initial and the final position. Here, your initial position is this, and your final position being this, the shortest distance here will be this straight line, which, if you know the Pythagoras theorem, can be easily calculated to be 50 meters. So here you can see that because we changed our direction, the distance covered and the displacement covered started to differ from each other, which is the case most of the times. You will see that the displacement is always lesser than or equal to the actual distance covered, but it will never be greater than the distance itself. Basically, there can be numerous different paths that a person can take and can cover different amounts of length to reach from one point to another. But there will always be a single shortest distance between any two given points, which is basically the displacement. Now, having cleared the fundamental differences between distance and displacement, let us get back to our previous topic, speed and velocity. Suppose in our previous case, you took 10 minutes to reach your school from your home. Let's find your speed and velocity in this case and check the differences between the two. Here, the speed with which you traveled will be the distance you covered divided by the time you took to cover this distance. Now, if you see, I have converted both these quantities into their respective SI units, which is the first step for solving every single numerical problem. Always convert your quantities into the respective SI units before performing any computation in science. Now, by applying these values in our formula, we can easily find our speed, which in this case is 5 meters per second. Your displacement here is 1.5 kilometer, which is 1500 meter. And the time taken is again the same, which is 10 minutes or 600 seconds. So if we replace these values in our formula of velocity, will get the velocity to be 2.5 meter per second towards the northwest direction. So, your speed of transit was 5 meter per second, whereas your velocity of transit was 2.5 meters per second due northwest, which is much lesser than the actual speed. And this happens because displacement is generally smaller than the actual distance covered. Do you know there can even be cases in which our displacement and velocity is zero? Let's check an example for that. Suppose you're running in this track which has a distance of say 400 meters and you completed your race in 100 seconds. So your speed in this case will be 400 meters, which is the total distance covered by you while running, divided by 100 seconds, which is the time taken to complete the race, which gives your speed to be 4 meter per second. Now, before you try to find your velocity, can you first tell me the length of your displacement? See, if you started from here, it means that your initial position is this. And after running this whole track, you reached your finishing line, which is again the same point from where you started initially. So here, your initial and final position is the same, which means that your total displacement here is 0 because you are back again to the same position from where you started. So here your velocity will be 0 meter per second, as 0 divided by anything is 0 itself. Now before I end my today's class, let me just summarize some of the differences between speed and velocity. Speed is the distance traveled by a body per unit time, whereas velocity is the distance traveled by a body in a particular direction per unit time. Speed can also be defined as the rate of change of distance, whereas velocity can be defined as the rate of change of displacement. The formula for finding speed is distance upon time, whereas velocity is displacement upon time. Speed is a scalar quantity, which means that it has magnitude only, whereas velocity is a vector quantity which has both magnitude as well as direction. The average speed of a moving body can never be 0, whereas the average velocity of a moving body can be 0. So this was all about speed and velocity. I hope you people might have understood everything about today's topic. I'm done with today's class and we'll meet again in our next video. Till then, take care and be safe. Thank you.